Hi everyone, welcome to Tech with Rohit. I'm Rohit Vinay. So today we are going to discuss on this topic recursion. Most of the software developers know its value and what about it. Recursion means a function calling itself at a particular condition or up to a particular condition is known as recursion. Here we have a particular condition means we have two conditions. One is base condition, another one is recursive condition. So before jumping into the topics, let's see what is the purpose of this recursion. So purpose is when we have a big thing, big big complex problem, breaking down into sub problems will make it will make very easy to solve the issue, and it is a easy approach, right? So that is only the purpose of the recursion. This statement we will understand when we are solving more recursive problems, more recursion problems. We will start from the very basic one, and we will go on. We will do a few recursion problems in this series. So there are mainly two parts in recursion. I already mentioned. One is base case. Another one is a recursive case. So what is base case? What is a recursive case? Before jumping into those topics, I will move to paint tool to explain recursion and what is happening in stack. These topics I will explain by moving after moving to paint tool. As guys, we are in paint tool. So here I just want to explain recursion in a pictorial way. Here our function is calling itself at a particular condition, and it is going to end at a base condition. So that is what is going to happen, that we are already discussed about. We already had a discussion on this. So what if we don't have base condition, if we are in a recursive condition, what it will happen? The function will call itself, and it will call the function will call itself, let's say example n times, and what will happen? So what will happen is, like, usually every function that we are going to uh, call is going to be in stack, right? So uh, the main function will be at the end, and the function something we are passing, if we are passing function and n equals to 1, that is the next function, that is the next function. And if we are exhaust our memory, our stack memory, we will get one error, that is stack overflow error. So to not get this error, and sometimes to get the value as well, we need to have recursive condition and base condition as well. So these are very very important in recursion. So when coming to stack overflow error, this is one of the big error, big disadvantage for recursion. We will discuss about this in detail when we are discussing about advantages and disadvantages. Let's have a small view of recursion and how it is going to happen with the universal example. We already know we already know from the so many years, that is factorial. Okay, let me give you a good intro about factorial. What is a factorial? So you will have this kind of symbol after that particular number. Let's say 4 factorial. What it's mean? So it's mean 4 into 3 into 2 into 1. The value of this is factorial of 4. So what is it? 4 3 is 12, 24. Yes, 24 is factorial of 4. So you may ask, what is the intention behind it? Okay, what is the intention behind it means, let's say I am asking for 3 factorial, Okay, I want a factorial of 3 factorial, let's say. And what will be the answer? So first we have to take 3 and next 2 and next 1, the value will be 6, right? So here you can observe the 4 factorial means 4. Okay, so let me use different color. 4 into 3 factorial, right? We can say 4 into 3 factorial. That means 4 factorial equals to 4 into 3 factorial. Like this we can divide into multiple things, like 3 factorial we can again divide it into 3, like sorry, 3 into 2 factorial, and again 2 we can divide into 2 into 1 factorial is nothing but 1 factorial is nothing but 1. So here you can see one problem we can divide into multiple sub problems. Like sub problem means it should also replicate the main problem, right? So should replicate this main problem, so that in that way we can divide it. So here in this kind of issues we can apply recursion. Usually we don't need to solve 4 factorial, we can simply use a for loop. But by using factorial, uh, what we can make is we can make the problem into, uh, as we already mentioned, we can make the problem into sub problems and we can solve them, and we can use the same thing for very very big complex things as well. So what is our next step? Our next step is we found the solution of this, and we here we will write two things. One is base condition. One is base condition. Okay, what is base condition? Here the base condition is if factorial, okay, factorial of less than 2, factorial of less than 2. If you ask this function what is a factor of less than 2, then what we will do is we will simply written as 1. Okay, or else we can simply say if factorial is of n, and n is less than or equals to 2, or sorry, less than 3. Okay, let's take less than 3. Then what we will written is we will just simply written n. Why? Because factorial 2 means 2, factorial 1 means 1. So if we know factorial 2, we don't need to calculate about factorial 1, right? So that's why this is the base condition. And what is we are talking about, we already mentioned about one thing, right? That is recursive condition. Recursive condition. So what is recursive condition in this scenario? So here the recursive condition in this scenario is, okay, here the recursive condition is if n is greater than 2. If n is greater than 2, we will simply ask, okay, let's all make it into black. We will just ask this function to return n into factorial of n minus 1. That's it, right? If n is equals to 3, what we will do? 3 into factorial of 2. And at the time of factorial 2, we will get the value as 2, right? According to this function. So we retrieved what is the base condition, what is the recursive condition of factorial problem, but the very basic recursive issue, factorial problem. So next we will dive into the Visual Studio, and we will just write the code to get the factorial of n. Okay, so let's move to Visual Studio. So we are in Visual Studio, I just opened a console application. Uh, it's just a this is a basic hello world program we have. So uh, let's write the factorial recursive function. Okay, I will just start with what what the factorial will return. So first it will return a int, and I'm just giving the same name factorial. What factorial is going to take input? So it is going to take a input that is number, 19 number or n, we can give anything. So here, as we already discussed it before, so here first we need to give what is the base condition. If number, what is the base condition? If number is less than 3, okay, if number is less than 3, then return number. Else, okay, we don't need to provide else. Okay, return n into factorial of what we call n or n minus 1. So it is n minus 1 only, or n plus 1. Okay, the intelligence is wrong, but so this is what all about factorial. So I'm saying that it is all about a factorial, and you might have some uh, doubts. So let's check it. Int result equals to factorial factorial. So here it is not a static function, right? So we need to provide static to access it from any point. Okay, uh, so factorial of 4, I'm just providing it. So as it is a static function, we can access within our class without any without even the class. So usually if it is out of the class, we need to provide program.factorial, right? So here we don't need to provide, as it is instead of the class only. So it is inherit it is like the it is a relation between class and the static method. So it is a completely different topic. So okay, so here what we will do, we will just simply console write result. Here we are not going to show the result. We will just simply check it by using debugger. Let's run it. I'm just running it. So here you can see the debugger is here and the result. When you hover on result, the result it is showing 24, right? So this is what the result. So let's check with any another number. Let's say 5. Okay, now what we have to get 24 into 5. Yes, 24 we already got 4 factorial, right? 24 into 5 equals to how much? 120. I hope it is correct. Okay, let's do it. Run a recursion. So when you hover on result, you are getting 120. So yes, this is how it is going to happen. It is going to work factorial. So yes, this is all about the first recursive problem, that is factorial, the most famous, most basic in recursion. So in future we are going to cover much more, like we are going to cover all the remaining not all the remaining, some of the popular remaining recursion problems, okay, in future. Thank you.